Okay. Jake, have you seen this? This is the new environment we use for 200. It's called Alice. It's made by Carnegie Mellon for teaching programming.
Why didn't you put the devil in?
Well, because they give you, what's cool about it is they give you all of these like starting points for bipeds and stuff like that. They don't have one in here.
The ogre will do.
They have a baby Yeti somewhere.
Yeah, I remember you.
But in any case, they came out with version 3 of it, which seems to be fairly capable. You can do a lot of cool stuff. All right, so for our homework for today, we looked at some various places to store our data, right? All right, so let's just call it data storage. All right, so we looked at what, MongoDB? We looked at FireBase. We looked at Amazon Web Services. Probably specifically S3. What else do we look at? Google App Engine, right? Okay, so let's start off by trying to describe each of these. Just giving it kind of a one sentence or a 2-sentence elevator pitch. So if you were a representative for one of these places and you bumped into somebody in an elevator, what would you say? So what's MongoDB? Pros, cons, who would use it? That kind of stuff. Did all speak at once.
Speaks JSON like natively rather than using HTTP and then parsing and unparsing JSON. Like it actually speaks JSON.
Okay. So it's a no SQL, right? And everything is native JSON. Okay. So, all right. So there isn't a conversion between JSON. It stores things in JSON. It transmits things in JSON over and over. Okay. And you think that's a good thing, right? Why is it an advantage to store everything in JSON?
That's already what we're going to be sending it as anyway. So
okay.
That makes, we're all going to be like thinking that way, I guess, is how I would describe it. But
okay.
There's the trade-off that how that functions like logically could limit you in some ways. So I was trying to read more about that, but I struggled to find it.
So maybe like JSON limitations?
Sure. I mean, like I guess what you could say is it's good if you're what I think I read, like you have collections, with collections in there, and as opposed to maybe I'm trying to think of what the other example was when it would be not so good, but I know it's good if you have like nested collections basically.
Okay. I mean, most of that is because of how JSON's array model works.
Yeah.
So JSON allows you to have arrays of arrays of arrays of objects of arrays, and so on and so forth. So the kind of the starting argument there is that so it's native JSON, and that's good because when we think about our internet aware applications today, we're sending and receiving stuff in JSON anyways, right? So why not stick with the format that we're already using in terms of how we are communicating with the database? All right, so when we think about an object representation of one of our objects that we might create in one of our languages, we would probably represent it in JSON. And then if we're going to store it, why should that JSON have to be turned into something else when you could just store the JSON because that's the representation of an object? Okay, fair enough. So that's what's good. So native JSON, which is the same as the data representation we are already using. Okay, so that's a good thing. You mentioned that there, in certain circumstances, there could be a performance problem or whatever, but that's probably a true statement of every single database storage thing. So probably not worth mentioning that. Anything else good or bad about MongoDB? Okay, so system resource, probably true of most of them. Realistically speaking, those are, in terms of modern software development, I mean, a lot of memory for MongoDB is completely different than what we might consider as like a lot of memory for like a big video game. So, a lot of memory for MongoDB maybe means it uses 30 or 40% more memory than a similar database management solution. And from our perspective, that's not really a big deal. We have plenty of memory and stuff, right? All right, so maybe throw the memory problem out the window. Not really a deterrent. Anything else good or bad you want to say about MongoDB? Okay, so tell me about the replication. So this relates to the idea of having lots and lots of things hitting it at once, right? So when you have the same data being retrieved from many simultaneous requests, you're saying that MongoDB has some built-in facilities for making that faster. Okay. So we'll say has capability of replicating data automatically to support scalable applications. Something along those lines. Okay. Got a decent elevator pitch for MongoDB right now? All right, what about FireBase? Okay, so probably its biggest feature is the idea of real-time updates to all connected clients. So if one client updates something in the database, all other clients become aware of that update automatically. It's kind of cool. In fact, actually something that really supports that becomes a problem, and we're going to talk about this on the backswing. We're going to talk about how a chat server might be implemented, and that has its own downsides. Typically, we would say chat servers, that idea of a chat server sounds like it should be pretty simple, right? In practice, implementing a chat server is actually quite complex. It's a difficult problem to solve, so we'll talk about that at least at a high level today. All right, so FireBase, real-time updates to all connected clients. What else? Okay, the implementation of, to use it. So if you're using their REST API directly, it's quirky, it's complex to use. Anybody else find that a similar?
Well, in MongoDB it is provided with REST as a REST API that is already inbuilt in the MongoDB.
Okay. So actually related to something that I want to talk about here. What APIs does FireBase have built into it that we might be interested in? Okay, so has built-in support for Node.js, I think FireBase has an iOS SDK directly, don't they? Yeah. They have an Android. They probably have some other ones too, but that's pretty much covering the things that we're specifically interested in. Now, the catch-all for any of these things is the REST API. So pretty much every one of these is going to have a REST-based API that we can interact with if they didn't already provide us with a implementation of the API specific for a technology. So for FireBase, we wouldn't use their REST API if we were using Node, iOS, or Android, because they have implementations of their API. They have software development kits for those three platforms at least that would allow us to more easily talk to them without having to use the RESTful API. Now, all of those are implemented in terms of the RESTful API. So really what it is you have a RESTful API, and then they decided, okay, well, let's go ahead and let's write the iOS version, a set of objects that know how to talk to a RESTful API specifically for the iOS developers so that their life is a little easier. They can just immediately start working with FireBase. Same thing with Android. Something I noticed this last week in Android Studio, which is the Android development environment, FireBase is built into it. So you actually, I haven't used it, but that product, that is something that there must be some sort of collaboration between Google and them, which also then leads me to believe that it's possible that FireBase actually uses App Engine as its backend. Not sure if that's the case or not, but that would be a suspicion.
I read that it was built on MongoDB.
Wouldn't surprise me at all. Most of these are. Parse is built on top of MongoDB, so it wouldn't surprise me that FireBase is. I'm just have a suspicion, since it was built into Android Studio, that maybe there's, yeah, or it's entirely possible that App Engine, that their storage implementation is built on top of MongoDB. Now, having said that, if there are, so for instance, I mentioned Parse, which is something that I've used quite a bit in the past, but they're phasing it out, so that's why we didn't have it as an option here. They definitely use MongoDB as their backend. So if you have all of these data storage options using MongoDB as the technology behind the scenes, might that lead us to believe that MongoDB maybe is a little bit less friendly to work with if these other companies are building abstraction layers on top of MongoDB? So we have our database, so JSON from a MongoDB perspective, which then has this MongoDB library sitting on top of it, which you can interact directly with. Or we could throw another library on top of that, which knows how to talk to MongoDB, which knows how to talk to the actual data. And it seems like that has become somewhat of a common practice. You mentioned FireBase. I know for a fact Parse is built on top of MongoDB. FireBase, he said he read that it was built on top of MongoDB. Would not surprise me at all. So it's certainly a thing that some of these places are building their technology on top of MongoDB, which leads us to believe that maybe MongoDB is a good technology from a performance perspective, from a this is how things are done today perspective, but maybe it's not as user-friendly as it could be. Is that a fair, maybe fear? We're going to find out, because we're going to look at MongoDB today, because I want to teach you as a buzzword out there today. Have any of you ever heard of something called the mean stack? You know what it means? Yep. Yeah, the mean stack is four technologies that supposedly work very well together. So we're going to go through a tutorial today and explore MongoDB from that direction, and then go from there. But it is a skill set that is in very high demand in industry. And one of the things that we're going to try to answer when we come out of the idea about the mean stack is it appropriate for mobile front ends, or should this really be in the web world only? And that's really the argument we're working with here, right? I mean, clearly MongoDB is perfectly acceptable. All of these are perfectly acceptable solutions, right? I mean, you have two big enterprise guys. Amazon Web Services is probably the biggest fish in the web world out of these in terms of cloud storage. I mean, but they're really focused, we'll talk about them here in a second, but they're really focused on enterprise. That's their, if you're a huge company that needs huge types of availability and speed and flexibility, all this stuff, Amazon's what you use. at the cost of it's impossible to work with. It's kind of the other side of it. So we'll be exploring MongoDB a little bit today from that perspective, and then we're also going to want to explore FireBase. All right, so having said that, FireBase has many built-in software development kits. So they have things that they have personally implemented to support their platform. So you can pretty quickly get up to speed with Node, iOS, or Android, as well as some other ones with FireBase. Because we no longer have to work with the RESTful API directly, which may or may not be complex. I don't know. I don't know the answer to that. What about MongoDB? What about availability of API or software development kits for talking to their REST API? Well, REST API is a little bit of a weird. MongoDB really isn't a REST API as much as it is just a local thing. I'll just leave it at REST API. It's fair enough. It kind of means the same thing. It's our way of communicating with it. So does MongoDB have native support for Node? Yep, definitely for Node. The mean stack thing probably gave that away. These guys are basically, they barely can communicate. No, so it definitely has strong support from Node, and we'll be looking at that today. What about the mobile side of things? So let's keep it kind of within our project. So iOS, Android, do they have, is there a convenient way for us to have an iOS app or an Android app talk to a MongoDB? When we, and we'll see this today in practice, but when you install MongoDB, is MongoDB a place? Like Firebase they have a website. We go there, we create an account, we create a database on there, and we connect our app, whether it's Node or our iOS app or our Android app. We teach it how to talk to that database in the sky, right? Is that how MongoDB works? So MongoDB is like a local database we bring down, and then after we have everything implemented, we can then migrate it to a place where that's going to hold our entire application. So we were talking before class about Heroku. That's a place we'll look at. So MongoDB is really a different kind of animal, right? It's like a local storage solution that sits next to our application, and then it will move with us when we put our application someplace else. So it's not really a place as much as it is just a technology. All right, fair enough. So with that in mind, we get the flexibility of deciding where we want to put it. And we also get the burden of having to decide where we want to put it. I mean, those are both problems, right? I mean, on one hand, well, I say they're both problems. They're both features and or problems. It's nice with Firebase where we don't have to make any of the decisions. We just use it. And Firebase, they implemented in terms of whatever. MongoDB, we don't care because we're using Firebase's SDK from the various technologies to store crap. It's going to get stored somehow, and it's going to get stored somewhere, and all we have to do is put these 3 little lines in our program, and it knows how to talk to the magical database in the sky. All right? Where Mongo, we have to micromanage it a little bit more. Maybe a good thing, maybe a bad thing, probably depends on the application. But now in terms of built-in SDKs, so that kind of drives that conversation as well. So you mentioned that Node has specific knowledge of MongoDB, right? And really what that means is that we can install MongoDB through NPM, the Node package manager we looked at last time. So it's less about Node talking to MongoDB through some sort of pre-designed software development kit, and it's more like Node can install MongoDB next to itself, and they're almost speaking the same language. It becomes like MongoDB is a Node package. Okay, so that leads us to believe that MongoDB might be a very, very, very good technology if we're only using Node. But now we have to start questioning, well, what if we have a iPhone application like we're going to have that needs to store something inside of MongoDB. Or if I store something in our database, if it's MongoDB, how do we get it in there? How does our iPhone talk to our MongoDB?
Through Node or wherever we store or wherever we put MongoDB. Could also, I don't know, have something.
Okay, so it's possible that there are some of these third-party storage locations like a Heroku or something like that that may expose an API to MongoDB for these different platforms. But generally speaking, we would have all communication with MongoDB happen through Node, happen through Express. So our iPhone or our Android app would make RESTful API calls to our Node server, right? To our Express server, which would then talk to MongoDB on the iPhone's behalf. All right, so we have to decide, is that preferable that all communication from all different clients all come through the Node server and then talk to the one database? Or is it preferable to have the communication from the website of things go through Node, talk to the database, communication from the iPhone goes directly to the database, communication from an Android app goes directly to the database? So do we want to have 3 different ways of getting to the same database, or do we want to have one way of getting to the same database? What's the pros and cons of each? One way, we control it, because we're going to be writing our Node endpoints. We're going to decide this is how you store a request for snow removal, something like that, right? And it'll be done one way on the Node server. And then we have all of our clients talk to that exact same endpoint, whether it's the website, whether it's the iPhone, whether it's the Android. They're just talking to our Node server's endpoint, and it does its thing, right? Okay. So certainly not a deal breaker there, but certainly a thing, something for us to consider. Okay. What about Amazon Web Services? Pros, cons? We kind of wrote like a paper on this, right? So we all should have quite a bit to say about it.
The input-output rates on the EBS versions are comparatively poor in Amazon Web Services.
See, didn't you do the programming assignment?
I did.
Yeah, so why is he answering all these questions? He didn't even do the paper. Did you do the paper? You wrote the paper too? That's a diligent student. How'd the programming go? Not too bad?
Like you mentioned earlier, what I think I was looking at all their like suite of products, and the one that we would maybe use was like DynamoDB or something like that.
Mm-hmm.
It's free. You get to keep the storage after your free period or whatever. And I think they gave you like 25 gigabytes, which is a lot, possibly more than we would even need, but at the cost of, like you said, tough to use.
Okay, so would it be fair to say, so you said DynamoDB, does that sit on top of S3? Yeah, I'm not familiar with Dynamo, but S3 is their storage solution, secure storage, secure socket storage or something like that. I don't remember what it stands for, but it wouldn't surprise me if they have an abstraction layer, probably built on MongoDB. All right, so Amazon Web Services, would an acceptable elevator pitch be high performance, high entry, complexity, something like that? So probably, this would probably be the Ferrari out of all of these in terms of abilities, but it's probably the I don't know, the car that doesn't have a steering wheel. The Ferrari without a steering wheel out of all these, where you have to invent your own steering wheel to drive it. Go ahead.
On Wikipedia, the last sentence of the background of it, it says that it is used to power Amazon Web Services such as S3.
Okay. So Dynamo is the actual storage. S3 is the technology that utilizes the storage. Fair enough.
There is a combination between MongoDB and DynamoDB when storing JSON kind of stuff.
Okay. It doesn't actually use MongoDB? It has a similar, it uses the JSON idea.
Using the JSON idea, I mean, the document store model, they implemented DynamoDB.
So it's a NoSQL solution, right? So similar mindset to the NoSQL, MongoDB, make everything JSON.
Especially, I mean, dealing with the Node.js application.
Okay. What about built-in SDKs? Would there be convenient ways for our Node server to talk to Amazon Web Services? Or iPhone app? Or Android apps? Are these provided by Amazon, or are there third-party implementations for a lot of these things?
There's a Node.js one that's supported by Amazon.
Okay. So native Node.js support. Anything else? Are we pretty much looking at a similar thing to our MongoDB, where we would now be passing all communication through our Node server? Yeah.
It does say that there is libraries and documentation for iOS, Android, and FireOS, which is probably their Kindle or whatever.
Oh, right, it would be. Okay. So let's say possibly for iOS.
It does have SDKs.
Okay.
AWS has almost all kind of SDKs. Every platform they need to talk to.
All right, what about Google App Engine? What's the elevator pitch for this guy?
There is no exact Node.js SDK available in the Google App Engine.
Okay.
They mentioned a document like we use virtual machines, we make a system out of the virtual machines and enable them to contact with the Node.js.
Okay. So Google App Engine, they store their stuff somehow. They don't really tell us that it's JSON based, or they just say, I think what they kind of advertise it as, they store it the same way Google stores all their stuff. You're using the same technology Google uses behind the scenes, right? Okay. So not necessarily this NoSQL thing where everything's in JSON, although it might be, but that's not an advertised thing. Realistically speaking, do we necessarily care about that if it doesn't inconvenience us? I mean, we don't care if it speaks JSON. Just if we send it JSON and something on the back end can just convert it into the weird made-up language that it internally uses, we don't care, right? We send it JSON, and if it spits it back out to us in JSON, we're fine with that too. So who cares if it did a weird magical Google conversion on the back end? Okay, so that might not be a big deal, but certainly something we wouldn't necessarily claim it has. What else? So what's good about Google App Engine? I got nothing to say about it. The server has
near to none downtime.
Okay. So high uptime. I would suspect that's probably true of Amazon Web Services. So MongoDB, your uptime and stuff is going to be probably dependent less on Mongo and more on where you're hosting it. And then FireBase, I don't know what their record is for uptime or whatever. I'm sure it's probably pretty good, but I doubt they can claim numbers that Amazon and Google could claim. Chances are FireBase probably hosts on Heroku, would be my guess. So it's probably so if we're based on the fact that you read that it uses Mongo, it's probably a Node.js server running with MongoDB that's living on Heroku, would be my guess. Heroku has pretty good uptime, but still it's not an enterprise solution like these guys. It's a lesser enterprise solution. All right, so Google App Engine, we'll call both of these guys enterprise solutions. Same thing here. All right, what else? Okay. A lot of documentation. To do implementation using Google App Engine, what are our implementation language options? Because Google App Engine is kind of an all-in-one product. For instance, we could write a Node server that talks to Google App Engine, but that's not the preferred way of interacting with Google App Engine. You create your own endpoints using Google App Engine. So instead of using Express, you're writing native code directly on Google App Engine that you upload to their servers. So they have kind of a competitor with Express, right? Is that a fair enough assessment? Okay. And what's that technology based on? We have 3 different languages we can implement that Google App Engine applications with. Java, Python. Is there a PHP?
Yeah.
Oh, then there's 4. Yeah, Go. Google Go. I didn't know they had a PHP. Interesting. Okay. So probably an enterprise application is likely going to use the Java implementation. It started off as a Python only implementation. Java's probably become its more flagship thing. Go is a very new thing. I think Go might still be advertised as experimental. I'm not sure. Let's say maybe. I didn't even know PHP existed, so chances are that's experimental, or I'm just out of the loop. So one of those 2 things. Okay, so is Google App Engine better or worse than Amazon Web Services? If we had to pick one of those 2, so those 2 are kind of in the same category with each other, right? Kind of enterprisey type thing. This guy's a platform as a service. This guy's an infrastructure as a service. So maybe Google App Engine has some more predefined ways of doing things. There's a lot of documentation because there's the Google way of doing it, right? As opposed to Amazon Web Services, where you basically are just given access to an OS that has some libraries that you can use to talk to, but you pretty much are implementing everything yourself. That isn't to say there aren't plenty of examples out there, but it might be difficult to find an example for the exact thing you want to do on there. It seems like maybe Amazon Web Services has a clientele of enterprise customers with unique solutions. Like the example I use, like Netflix. Netflix is one of their clients. So they have a very unique solution. So if you're trying to do something with video, chances are, well, A, you're not going to find Netflix giving you tutorials on how they implemented some proprietary technology. But even if they did, it's likely going to be different than the problem you're trying to solve. So maybe the assumption might be that there's less useful documentation for Amazon Web Services out there for the common application. So Google App Engine maybe wins the documentation war there. What else?
Doesn't support multi-threading.
Which doesn't?
Google App Engine.
Google App Engine does not support multi-threading. All right, so I'm trying to think what the context of that might be. So I'm sure there's multi-threading. I'm sure multi-threading exists. So you're saying that it doesn't allow us to specify multiple threads. So we can't, as a user, say, I want to spawn off something to go work on this. Instead, you just make your request and let Google App Engine figure out the best way to serve it. Fair enough. I'm not sure if that's a positive or a negative thing, because I know you can make multiple requests at once. So it might as well support multi-threading from that perspective. It almost talks about this, talks about the idea that from a programmer's perspective, we don't have to solve that problem. We just say, I want this to happen. I also want this to happen. Go, make it happen. And it figures out if there needs to be threads spawned off to make these things go down or whatever. Okay? Anything else we could say that's a kind of a competition between Amazon Web Services and Google App Engine? For our application, if we were forced to choose between Google App Engine and Amazon Web Services, which would we choose? You would choose Amazon Web Services. Okay, why? Okay, so specifically because we could stick with the Node side of things. So, okay, so since we've kind of picked Node as Node will talk to Amazon Web Services, where, there's no reason why Node can't talk to Google App Engine. It's just kind of solving the same problem twice, right? We're having our website or our app talk to Node, endpoint XYZ on Node, and then it's talking to endpoint XYZ on Google App Engine. So you really have Node twice. Google App Engine and Node are kind of equivalents from a server perspective, except Node doesn't have native storage. You could bring storage in. App Engine does. You store the App Engine way. All right, so we could use App Engine, but using App Engine means that it would make sense for us to move away from Node, right? Because then you actually are serving your entire websites through Google App Engine as well. So you would effectively be replacing Node to get the storage of Google App Engine, because Google App Engine replaces Node. So Amazon Web Services would give us just the storage capability without having to trade out Node. Mm-hmm. Okay, fair enough.
Even though we have a lot of document, the same thing available in the AWS.
Okay.
If there's a chance between both of them, I'll go for AWS.
So now let's look at the first two. Let's look at MongoDB versus FireBase. Which do we pick out of those two and why? That's a tougher one, right? So we're going to check out MongoDB today specifically and get a feel for it, how it works with Node.js, and we suspect it's going to work pretty well. Right? We'll see how this tutorial plays out. It uses this new Express framework thing that creates a structure similar to Ruby on Rails that we had talked about. So that'll be some fun for a couple hours tonight. So we suspect it's going to work pretty well with MongoDB, Node.js. Fair enough. And I can tell you that on the iOS and Android side, there's plenty of kind of REST-capable SDKs out there for talking to RESTful APIs. So if we're writing our own RESTful API in Node, it wouldn't be prohibitive for our iPhone app to talk to our database through Node. Might not be as convenient if you've worked with Parse or something like that before, to just directly talk to the database, but it wouldn't be horrible. We could actually just write our own classes that would then make it convenient. When you really think about, for those of you who have worked with Parse before, Parse's magic all lives within PF object, right? After you've worked, so we would just invent our own version of the Mongo PF object, where it would just bring in JSON representations of stuff, and we would ask it for its value. It would give us its value. And so a little bit of upfront coding we would have to do, but we could create that convenience. Okay. So in FireBase, it seems like we wouldn't have to do that upfront coding because it's going to have those objects that allow iOS to conveniently talk directly to the database, for Android to conveniently talk directly to the database, and so on and so forth. So which do you choose between these two for our project?
think like Firebase has limited support for querying data, whereas MongoDB has different aggregation framework and also MapReduce to query a bunch of huge set of data, some kind of.
So Mongo would lend itself to big data, where Firebase would be more consumer level.
Yeah,
Okay.
like previously mentioned, quick response to the data manipulation.
Okay. Do you think in our application we would likely notice? Do you think we would notice any sort of real performance difference between MongoDB and Firebase? Or are both of these guys probably going to handle what we're trying to do? Yeah, I mean, there might be some differences behind the scene, but in terms of our experience and the end user's experience, probably not a substantial difference there. So how do we pick one? Let's think about the nature of our application. So first of all, the nature of our application is this idea of we have a web and we have mobile, right? But we also have a core part of our application that deals with the idea of two different groups: consumers making requests for rides and providers becoming aware that a request was made. So there's an advantage for us to have real-time data updates, right? That's really the key here. So even if the rest of what Firebase does sucked, the fact that this really leverages exactly what we need, the idea that we can have an iPhone app for a service provider plugged into the database, an iPhone or a website for a customer plugged into the database, and when this person makes the request, the service providers instantly get the response, see that request because they're screen updates. That seems to be advantageous for us, at least on the surface, right? It seems to solve a problem that we're legitimately going to have. So having said that, let's talk about this idea of a chat server for a few minutes, just generically, not with any specific technology. We want to think about the model for a chat server. So let's say we were asked to write our own chat server. Okay? What does it mean? So all of us, we've all connected to a place somewhere, right? So we're all sitting at our computers and we've connected to some centralized server. Now, we're all dumped into the same room, so we'll just pretend like this is the room. When I say hello, all of you see hello, right? And so you'll probably see Mike says hello, and then I'll see on my screen you say hello or something like that. Okay, now if you type something, everybody else will get broadcasted, I would get broadcasted as well. Now, that is easier said than done, the act of broadcasting to a whole bunch of people. All right, so what we have 3, 4, 5, 6, 7, 8, 9, 10 of us in here, right? Good number. All right, so now, what does it mean to connect to this server? That's the thing we want to kind of understand here. So if let's just kick it down here. So we have the server. We're not going to talk about the nature of that technology, just it's a server. All right, and then for us, we have 10 clients that we're going to represent as 3 clients. That's a client. That's a client. That's a client. Now, all of these guys have established communication links with the server. They need to be able to send data, and they need to be able to receive data. So if we're going to use this as a real life example, we're going to think about this like a conference call, right? We all dial into the same phone number and we're dumped into a shared phone call. So we have this one communication channel. So if this is me and my phone here, I could hear anything that's happening on this call. I could also say stuff on this call, right? And it all just kind of magically works. But if we're implementing a chat server, we need to understand how that worked. So we've connected to the server somehow. We don't know the nature of the server. We don't even necessarily need to talk about the nature of these connections right now. Just that it's a two-way connection. This guy needs to be able to send crap. He also needs to be able to receive crap. Fair enough? All right. Now, when he sends a message to the server has the job of redistributing that message out to everybody but the person that sent it. This guy knows what he sent, right? So the server doesn't need to tell him, by the way, you sent this message. It could. We could do that, but we wouldn't have to. So really, if we think about the job of the server, if this guy sends a message, these two need to be distributed that message. Okay? Now, how would that happen in real life? If I'm the server, okay, and all of you have opened up a communication channel with me. So I have 9 telephones sitting in front of me, okay, in real life. So each one of you have rung into one of the phones. You know, it's one of those whatever network things. So they're all connected. All right, now you send a message. So now what I need to do is I'm going to hear your message over this phone. I'm going to hear a little buzz here. I see a little light. There's a person jibber jabbering on this phone. So I'm going to listen to your message, and now I need to go and rebroadcast the message over every single other telephone. All right, so let's assume that I'm going to be able to mimic your voice. All right, so I'll pick it up and I'll say the message to him, then I'll say the message to you, then I'll say the message to you, and I'll say the message to you, so on and so forth, one phone at a time. So I have a collection of phones here, collection of communication channels. I just go through and I send it out to everybody except you. Okay, maybe I even decide to send it to you kind of acknowledging the reply, the message. Received, and that way you can spit on your screen that you sent this. And then I go and just go through my entire list of open connections, sending it out to everybody. Okay, fair enough. Now, right now we're all sitting in a room. So what we're talking about here is kind of landline telephones, right? How many of you have ever had a dropped call on a cell phone? Most of us at some point, right? Call disconnects or something like that. All right, so now this starts moving closer to the way the internet works. So now we're not sitting in this classroom. I still have the same 9 phones sitting in front of me, okay? But you guys are in different parts of the country. You're on the interstate. You're driving. Whatever it is. You're on the move. You're jumping between cell tower and cell tower and cell tower. All sorts of different points of failure. Now you're going to make a phone call into this. So we have nine communication channels. And I pick up the call. Now let's say that you get a dropped call. So Jake's going to send me a message. I'm going to now redistribute that message to everybody except him. And when I get to this last phone here to talk to you, I notice that you've been disconnected. So I cannot send you that message. But we wanted to be able to send you that message. Now, are you going to notice on your end that you've been disconnected? Yeah. So what are you going to do? You're going to dial back in, right? Okay, you're going to try to dial back in and reestablish that connection. Right? But for each one of these connections, we're going to call it's potentially an unstable connection. You need to pay attention to whether or not you're still connected because A, you want to be able to send messages, but B, you also want to be broadcast any new messages. Now, I also need to keep track of any sort of dropped calls here. So for no other reason than for me to say, oh, well, this call's been disconnected. I'm going to take it off my list of things to try. If he dials back in, I'll add him back to the list. But this is a dead communication channel sitting here. So I need to manage that as well. That way I'm not trying to talk to the wall, so to speak. So even though you're not there anymore, here's the message, and he's not receiving it because he hasn't been connected for 5 minutes. Something like that. All right, so we're monitoring these communication channels. Again, we haven't talked about what the nature of these channels might be, but we're talking about what they need to be capable of. All right, so every client needs to be, they need to be aware when new data is available, when something's been broadcast to them. They also need to be aware when the communication channel breaks. Now, in a conference call perspective, how are you going to find out that I've sent you a message? So if I pick up the phone and somebody says, hey, how are you doing? And I spit it out to each individual one, and I say, hey, how are you doing? How did you know that you got that message on this conference call? We've all been on a conference call at some point. How do you know that somebody said something? You hear them say it. Okay, you hear them say it on the phone call, right? So that means that all of us need to be sitting there and diligently paying attention to that phone call, right? So we don't miss anything. Usually we space out on conference calls, right? You just mute it and you go and do whatever else you're doing and pretend like you're still on the call. And then hope somebody doesn't ask you a question. If you hear your name, you're going to have to backpedal a little bit. You've been there, old Alex?
Yep.
Yeah. 3 or 4 hour call. I used to do conference calls on the golf course. Little Bluetooth headset, phone in my pocket, muted.
And when they say your name, you're just like,
Completely ignore it. I had priorities. Okay, so in real life, we have to pay attention to that phone call if we want to be part of that conversation. Now, I think we talked about design patterns, right? Talked about design patterns in general. We talked about MVC. We talked about anything else at this point? Nope. So let's talk about another design pattern called the observer design pattern. So this is a good example of this. And we saw this last time. Did we look at event emitters last time? Did we do that in here? We raised events and responded to the events and stuff like that. Okay. So that followed the observer design pattern. So I may have at least mentioned it last time. But the observer design pattern says that it is a good idea to be productive while waiting for something to happen rather than, and be notified when it occurs rather than stand there and check on the status constantly. Okay, that just makes sense. So if we're, this is the opposite of our modern conference call. Because even though we try to be productive and hopefully we recognize if we hear our name, chances are if we weren't paying at least a little attention, we're not going to know what the heck they're talking about when we finally hear our name, right? And so the reality here is that in the world of the observer design pattern version of a conference call would mean that each of us dial in and then mute ourselves and then go off and do whatever else we're going to do. And then we become notified when there's something that we might be interested in. That's probably the way we'd love for conference calls to actually work, but that's not the way they do work. We try to make them work that way, but we're not that productive in responding to the stuff. But this is the observer design pattern. And that's really what we want to have happen here as well. For instance, we want the server to be able to push information out to these clients whenever information comes in. The server is constantly listening for new communication and then pushing it out to all of these guys out here, as opposed to the clients constantly trying to pull new data. So we have kind of two options. We can have clients pull data. So now we're going to maybe pull the server every second, let's say. So every second, every client will ask the server, is there anything new for me? Is there anything new for me? Is there anything new for me? Over and over and over and over and over again. Now, that could work. But first of all, it's not real time. You might have a delay of a second. If you just missed the last message and it takes another second before you ask for it. You're also making a whole lot of unnecessary requests, right? So if none of us send a message for 10 minutes, there's a whole lot of, from each of us, every 1 second, we're asking for, are there any new messages for 10 minutes before there's actually another message? A lot of wasted time. So that's the concept of pulling data from a server. So we're going to say that's not really efficient because now these guys are too involved. They're not following the observer design pattern. They haven't established a communication channel and then gone off to do their own thing down here, only to be notified somehow when data is available for them. All right, so that's where we go to more of a push situation. So we've heard of push notifications, right, on our smartphones. So what does that mean? We're sitting here doing whatever, and USA Today just randomly sends us a message. Okay, something like that. We get a text message. Those are all push notifications. We're not constantly checking, do I have a text? Do I have a text? Do I have a text? We become aware when we get a text. We become aware when there's new data available.
Hopefully we're not checking like that.
What's up?
Hopefully we're not checking like
Well, you used to. I mean,
that. Like, people look at their phone every 10 seconds and check.
yeah, I mean, with flip phones, people that transition between when texting was popular, but before smartphones were a thing, people would just constantly check their phone to see if they had anything new. Well, later, not at the beginning, not when text messages first started. They had to figure out that was a thing. Some of them would just light up because you didn't want it actually buzzing, so you'd have like the little flash. Almost like I think I saw a phone one time. I think it was the Motorola. I don't know, one of Motorola's flip phones that had a blinking red light, almost like you had a messenger answering machine. That meant you had a text that you hadn't. Well, you had a text since the last time you flipped the phone open. Those used to be cool phones. You had the IT guys would keep it in like a little holster here. All right, so in any case, this idea of push notifications makes a lot of sense today, but push notifications can come in a lot of different formats. And I guess when I say format, I'm really talking about the delay. So when you think about push notifications on iPhone or Android, that's not assumed to be real time. It's hopefully close to real time, but generally speaking, if you get a notification from USA Today about this morning's job reports, do you assume this just happened 2 seconds ago, or probably something that happened sometime in the last 20 minutes or something like that? It's recent news, right? Now, having said that, there seems to be some enterprise models for making it more real time. Like I think I got all the push notifications for the results of the Super Bowl pretty much right after the Super Bowl ended. I was watching the game, and then all my different news apps started buzzing and stuff at me. I'm assuming Yenter, you were too busy and screaming and stuff. He's a Broncos fan. You got the Broncos hat on today too? What hat is this? What kind of Broncos fan are you? You're a crappy Broncos fan is what you...
He's just kind of bugging, man.
He's what?
He's kind of bugging, man.
Unfortunately, my hat went through quite a bit yesterday. What's this? See, really, the whole Super Bowl thing was all my fault. The whole fact that the Packers didn't make it to the Super Bowl is all me. Packers were undefeated. Broncos were undefeated. I traveled to Denver over fall break. 1 week before the Packers played the Broncos, 2 undefeated teams, showdown. Packers were the huge favorite. I took a picture in front of the stadium and everything, said, Broncos, get off the tracks because the train's coming through, right? And the Broncos blew the Packers out. And it was all downhill from there for the Packers. Because Yenter remembers that before that, the Broncos were considered to be a fictitious undefeated team. Yeah, people didn't think they were as good as they were. They don't deserve to be 6-0. They just got lucky. Now they're Super Bowl champs. What's that? That's true. I probably could have quarterbacked for the Broncos yesterday, and we still would have won the game. Because that was a ridiculous defense. All right. So in any case, this server is going to be pushing out information to our clients, but we need to rely on a technology because if we're in a chat room, we expect that communication to be pretty real time, right? Maybe not down to the point of a nanosecond or something like that, but certainly fast, right? If I send a message, I would expect all of you to receive that message within a second or two, something along those lines. All right, so we need to talk about how we can guarantee that. And this is going to be a multi-level kind of thing. And we saw it a little bit last time with the emitters, but that was all local. That was all on the node server, right? You know, the node server raised an event and then it received the event. But that's kind of like me talking to myself, which I've been known to do, actually. My wife has commented on that. If she's driving in the car behind me and she sees me in there, I have full conversations. Huh? Well, I do that as well. But yeah, just the full-blown conversations. Okay, so in any case, these guys, these clients that are not sitting on the same machine need to be aware. They need to have some thread, okay, some secondary process that's sitting here and monitoring these communication channels, but in such a way that it doesn't prevent these guys from doing something else. All right, so the real life example of that would be, you know, maybe I am, so let's go back to our conference call example. So I'm on the conference call on the golf course. And instead of me listening in on the call, I have a buddy there who's he's going to listen in on the call for me. I'm going to buy him lunch or something like that. Right? So he's supposed to keep tabs on stuff, and then if my name comes up, he's then going to notify me. He's probably going to kind of give me the 5-second version of what they just asked me, and then I'm going to answer so I don't sound like an idiot, right? So that's kind of what we're looking for here. We're looking for a buddy to monitor that call and who's going to let us know when something's happened so that we can actually deal with it. All right, that's what we're looking for over here on the client side. Server side now can rely on that because all they have to do is go through all their open connections, rebroadcast the message, knowing that every one of these clients will get interrupted by their buddy, that something's happened, right? Okay, so do we have a fairly decent idea how a chat server should work? Fair enough, that's kind of our modern focus on a chat server. Well, now we have the issue of what's that technology there? And that technology needs to change depending on the type of environment we're in. You know, we talked about a landline phone, you're probably not going to have a whole lot of dropped calls. Cell phones, you're moving, drop calls don't happen constantly, but you're going to have more drop calls. Certainly when we're, when we have a data communication channel like this, that's really reliant on data accuracy. A phone call doesn't rely on that much accuracy. Phone calls actually a very low bandwidth communication channel that relies on analog data because a human being's listening to it. So what's the worst that happens is a person breaks up a little bit for 2 seconds and then the human being on the other end kind of piecemeals the conversation together and says, oh yeah, you're fine now. And life goes on. So the communication didn't actually break, but it wasn't solid the whole time. Well, these need to be solid. This is digital communication. It's on or off, true or false, needs to be accurate. So we have to think about what's the nature of these communication channels. But in order to think about that, we have to think about what's the nature of the server. Historically, we say server tech. Historically, we might have a dedicated server that listens constantly for incoming connections and maintains those open connections. All right. So this has some downsides to it. One is, in our case here, we're going to have a machine that's on the internet that needs to be available to all of us to communicate to, right? Well, so that means that I have to have a computer that I'm willing to dedicate to this. I need to have an internet connection that is not blocked by a firewall or something that needs to be available to the internet. So that's going to cost money to do that. I'm probably going to have some bandwidth limitations for any sort of dedicated server like that, where I'm allowed to transfer X amount of data per month or something like that. Sometimes not, but there's some other rules that go along with that, unless I'm using my home-based internet, which you probably could for certain applications, but wouldn't want to for many applications, and most home-based internet sitting behind a firewall anyways. So bottom line is while this seems pretty ideal, this is also not as attainable today as you might want it to be. To get this set up where you have a dedicated server, you can write software however you want to write software, is probably going to run you $60 or $70 a month, something like that. Not ridiculous, but $60 or $70 a month that you probably didn't want to spend for that type of thing. All right, and this is to have maintained dedicated connections that you have full control over. Now the difference is when we start getting into this idea of web technology, we really have stateless type of connections. So when we connect to a node server, it's here's my request, thank you for the response, I'll let you know if I need anything else. And that connection's done. Okay, it's calling up, ordering your pizza, hanging up when they say it's on the way. Does that make sense? Well, chat server, that's maybe not kind of how it needs to work. Well, at least not the way we've described it. At some level in there, I need to be able to allow that server here. So if I'm going to call up and kind of join the server and then disconnect somehow, but still have a way for that server to communicate back to me, I need to have some sort of special technology to pull this off. I probably mentioned it last time with this thing called WebSockets. We talk about that at all? Okay, so WebSockets really solve this problem for us. So it's this idea of a telephone call that's maintained open, but in an environment where we cannot guarantee that these connections are stable. So instead, there is some magic protocol that lives between these guys where this guy maintains a unique ID, this guy maintains a unique ID. Behind the scenes, there is a communication channel, whether this guy is polling every so often to kind of check in to re-up his connection, let him know if his IP address has changed, that kind of stuff. Because all of our network-enabled devices all have unique IP addresses. And as long as your IP address is the same, that's fine. So even though I'm a moving target, you'll still be able to reach my device. But as soon as something changes, I need to have the ability to talk to the server and kind of update my communication, update my phone number with the server, if you will. So next time they need to reach me, they can call back. Similarly, the server needs to be able to talk to our clients whenever, and our clients need to have some mechanism in place for becoming aware that the server has sent some information without our clients constantly having to check in on it. All right, so we can just assume that that data exists, but it does not exist in this form today. Well, it's not that it doesn't exist in this form, this isn't the convenient way we would handle it. And this kind of becomes an interesting thing with software applications. I've seen it plenty of times, and it's kind of a common thing that people complain about. When an application comes out, people ask, well, why doesn't it have chat? Have you ever heard that before related to any app you've purchased or downloaded? Never necessarily came up. I've seen it several times where a community, like a lot of social media type applications, but not the big ones, the like secondary market socializing some little thing or something like that, will not have chat functionality. And most end users view chat as kind of a requirement, right? It's like, oh, what's the big deal? It's chat. That's something we've had for years and years and years. No big deal. Well, the reality is implementing a chat server is actually much more complex than it seems like it should be. That's why it gets omitted. And it's also fairly cost prohibitive. A lot of times you have a limit on the number of total connections. So for instance, even using WebSockets with a lot of technologies, they limit the number of concurrent connections you can have, for free. Otherwise, you have to pay a lot more for more connections or things like that. Now, having said that, let's say you could have 100 open connections at once. Is that enough? Well, for many applications, maybe even most applications, probably. If you're writing realistically speaking, is 100 open communication channels simultaneously good enough for many, many, many applications? Yeah, probably. Is it good enough for Facebook or Instagram? These guys have huge user bases. So the reality is there's a pretty big chasm between your really, really successful social media stuff and everything else. So average really successful one has thousands and thousands and thousands and millions of users. Everybody else has like 20 users, or at least 20, 30 active users, something like that. Maybe they have 5,000 total users, but how many are on at any individual point in time? That's all a moving target for us as well, trying to guess how many people might use our application. So when you're picking a technology, you kind of have to pick something that with that in mind. Like, okay, well, we all have this idea of grandeur, right? That the application that we're going to write is going to have zillions of users and wildly successful and all this stuff. Even though it probably won't be, but does that mean you don't design it to be able to handle 1 million users, just in case, right? We want it to support 1 million users, as long as it's not going to cost us too much, because you're always playing that game as well, right? Well, we were going to implement this to support as many users as we can support for free. Or maybe we're willing to spend $5 a month or something like that. So we're off the free trial. We're on their beginner basic plan or something like that. Okay. So certainly something we do need to consider here. And in our world, since we're going to have some kind of server, in our case, it looks like we're working with Node, and we have a whole bunch of clients, but we have two different kinds of clients. We have consumers and we have providers. There needs to be effectively chat functionality, right? They're not actually talking directly to each other, but when this guy, quote, sends a message, when he makes a request for snow removal, all of those providers need to become aware of that new request for snow removal. It's effectively a chat server, right? Okay, so when we go back here, this is the real intriguing aspect of FireBase. And I haven't used it before, so I'm not sure how good that is. We're gonna explore these two technologies. So we're gonna go down two different rabbit holes. All right, so what we're gonna talk about today as a starting point is this, what's called the mean stack. Let's introduce that here. Mean stack. So that is MongoDB, that's the M, Express, that's the E, Angular, that's the A, and Node, that's the N. Now, Angular is going to be, we'll mess with it a little bit, but this is probably less important for us. Really, this is database, RESTful API server, and then the underlying server technology. Does anybody know what Angular is? We maybe even talked about it the first day, did we? This guy's a front-end technology, right? So this is essentially a JavaScript library that runs within the web browser. So the idea of this mean stack thing is, well, in this world right here, is a lot of our communication with the server and with the database actually is happening directly through our client's front end, rather than making endpoint communications to our server. So we're not actually making HTTP requests to our server in the traditional sense, where we have a web form, you fill it out, you hit submit, it goes and does this stuff. We're handling a whole bunch of the stuff actually in the web browser. And it's updating little parts of the web browser with requests back. So that's kind of what Angular is. And we'll see probably a couple of small examples today. I think it's in that tutorial that we'll go through. But this is something called the mean stack. And to kind of put this in some context, there's this idea, kind of a fictitious idea, of a full stack developer. All right, so we have this idea of a full stack developer. And how many of you have heard that phrase before? At some point, job hunting or something like that. What does it mean to you when you hear full stack developer?
The developer can handle from the front end to the database level, all the stages of the application.
Okay. So generically speaking, we would say that there is a single person understands front end to back end to database, then we'll just throw in the catch-all, etc. in there. So one-man show, if you will. But this has been kind of a misnomer, because there's lots of different full stack compatible approaches. We're going to look at the mean stack for this, but generally speaking, the idea of a full stack developer kind of implies one person who knows everything. And that's kind of impossible in today's world, right? With so many technologies that are out there. And I've worked with this stuff before, and I'm about to see something new. The last time I worked with Node.js for doing Mongo stuff, it didn't use this middleman. So this could get real interesting, or I might be impressed. We'll see. But the point is that even if you try to keep up on this stuff, there's gonna be holes. So at some level, there's got to be a specialization, right? So full stack really didn't mean much. So what started happening is we started having this idea of, here are some common technologies that are often used together. And if you can become a master of those technologies, then essentially you've become an expert in something that is in demand in industry. And maybe one of the main buzzwords today, especially on the web side of things, is this idea of mean stack. So leveraging MongoDB knowledge along with an Express server sitting on top of a Node server, and then leveraging front-end Angular to talk to that server, to update stuff. So this would be considered a full stack type technology, but specific to these technologies. Make sense? All right, so we're going to explore this a little bit today by going through a kind of a tutorial that'll end up having us build some stuff. So we'll get rolling with it, then we'll take our break, and then we'll keep rolling with it. And then when we get done with it, we want to assess how well that's going to work for our world. Now, the next thing we want to do is we want to explore FireBase in class and see how well that's going to fit our world, because we want to experience that real-time communication. Because mean stack feels like it's, at least from buzzwords and stuff like that for us, it feels like it's very much the in thing to do, right? It's kind of if you can put on your resume mean stack experience, at the very least, it sounds like a cool buzzword. You can pretend like you didn't know what it meant or something like that. But, at the very least, then you've kind of set yourself apart at some level, right? So it seems like a good skill for us to learn anyways. Realistically, even if we don't pick MongoDB, we're mostly going to be getting mean stack anyways, right? Just using a different database. But on the same hand, because of the nature of the application we're writing, that real-time communication could be handy. Now, that isn't to say we couldn't write it ourselves. We could use WebSockets and basically generate that real-time communication for ourselves. Might be worth it. maybe we decide we don't want to reinvent the wheel. So these are some decisions we're going to have to make, but I think we're maybe backed into a corner from the perspective of we need to explore both of these technologies, maybe do some homework related to both of these technologies, and then be able to come back and make a decision. Make some sense? Okay. So I put a link up on our, if you want to follow along, I put a link up on Blackboard. I just called it like mean stack tutorial or something like that. Here's mean stack tutorial. Okay. Oh, we're also going to be looking at Jade, which is a template engine. So kind of the de facto template engine that usually goes into mean stack development. It's a part of NPM. You can get Jade, so they take us through that as well. All right, now some of this we've already set up, so we'll go through some of this. Sorry, push notification. All right, so let's see. Last updated near the end of last year. Yeah, that's where they put the new stuff in, yeah. Okay, so we're just going to jump down a little bit. All right, we already have Node.js installed, so we can skip past that. Yeah, here's this new thing, this thing called an Express Generator. This is a thing I have not heard of before. So let's kind of go back out to our, let's see here. There's our node test, node module. So I'm going to make a directory. In fact, actually, let me do it this way. I'm just creating a folder in my Dropbox. That way I can access this from different places, but I also send you a link to the Dropbox if I need to. Okay, so we're going to do our stuff in here. So we need to go ahead and do an npm install Express Generator. Okay, so that's this new guy that builds a directory structure for us, is at least my understanding. So remember when we talked about Ruby on Rails? I mentioned that one of the downsides of Ruby is they have a very predefined directory structure that you kind of have to follow. You have to do things the Ruby way. Well, with Express Generator, they've kind of done the same thing. They've said, well, this works on top of Express, so instead of having a single file that delivers everything, we kind of started writing last time where we were writing our own endpoints, this kind of creates a format for a directory. Even though you can deviate from it if you wanted to, it gives you kind of the right place to put some different things to make it easier to maintain larger applications and that kind of stuff. So we'll go through and look at some of those things. So I'll go ahead and do our npm install. Oh, here, I just need to do this. Okay. Yeah, it needed to write something to the /user_lib. So you needed, when I do a sudo, it runs it as super user. So it didn't ask me. It's kind of like on a Windows machine when they said, do you want to run this as administrator? Kind of the same thing. All right, so I have Express Generator in there now. Let's see if we can make this any bigger. All right, so we already got Node in there. Here we got Express Generator. Now we can create an Express project. So we're going to use Express and Jade. Okay, so I think we need to, because we're in a new directory now. Well, let's try it, see if Express is in here. So let's call this guy mean test. It's going to be what we're going to generate. Okay, yeah, it worked. Oh, because we installed Express last time globally, right? So that's why we had access to it. All right, so notice here that this went ahead and it just created a directory structure for me. It didn't necessarily do anything super fancy other than the fact that it said, here, I'm going to create this whole directory structure for you. So we have this package JSON. Here's your main app JavaScript. So that's equivalent to our little JavaScript thing we had last time. Here's public JavaScript. Here's a place for our images. Here's a place for our routes. Layouts. So here's some Jade stuff for our template engine thing. So we'll be viewing this. So this is kind of like a great starting point for saying, hey, you want to start making a web application that's going to do things the Express way? Here. Here's a good starting point. And notice the very next thing they tell us is move into your directory and then call npm install. And what that's going to do is it's going to read our package JSON thing, which is going to, we can look at it here in a second, but it's going to have a whole bunch of crap in it of things that npm is going to go ahead and install for us. So just like we did last time where we did Express, and I don't remember what else we did, but you know, it's going to install a whole bunch of stuff like Jade and things like that that are going to help us. Just for those of you who are interested in command line stuff, this $& says do this and then do this. So we can do it all in one line. Or you can just cd into the directory and then you can just type in that command. They both ultimately do the same thing. All right, so let's go ahead and do this. Well, I'm already in this directory. So I'll cd into mean test, and then I'll do an npm. Well, actually, let me just real quickly here do a cat package.json. So here's all our dependencies. So we have this thing called body parser, cookie parser. These are things for handling endpoints, for how stuff is passed into our endpoints. There's Express, there's Jade. I don't know what Morgan is. And this is a favorite icon thing. It's a web-specific thing for how to get, like, we've ever been to a web page where it actually shows the icon of the place up top. Does this one have it? No, one of these will. Yeah, this guy does. You see how this has like a specialty icon here? There's another one here. Those are called favorite icons. So there's a way to expose that from Node.js. So we'll go ahead and do an npm install, which is going to go ahead. Actually, I think they want us to add a few things here, if I remember from the tutorial, because they want us to get MongoDB and things like that in here. So let's just, before we do that, let's go back into the tutorial and make sure that. So it creates all that stuff. It tells us what to do. Yeah, it wants us to edit some dependencies. So it wants us to add MongoDB and Monk. So we still have serve favorite icon. We still have Morgan. We still have Jade, Express, debug, cookie parser. Okay, so we're just adding these two. What's it called? Package. So just two additional things in here so that we support MongoDB. And then I don't know what Monk is used for. I guess we're going to find out. It might be, I think it's probably a MongoDB API. So this is the actual database. This is the node thing for talking to that database. So I think is what this is going to end up being. All right, so go ahead and we modified that file. You could use any text editor you want. I just used VI. Then we could do an npm install. I'm pretty sure that's what they wanted us to do here. Okay, yep, there's npm install. So let's go ahead and get that guy cooking. Okay. Unmet peer dependency. MongoDB 1.4. Guessing this is fine. These are just warnings. This has to be a security thing. And this guy is actually, I bet. See, I usually don't put in these rough version numbers. I'm guessing there's a new version of MongoDB as well as Monk. That was MongoDB 1.4. Oh, that's weird. Oh, let's just assume it worked. I think those might be things that we don't necessarily need. All right, then we're going to we can always go back and do that install again. We're still just continuing our directory. So we're going to make our directory called data, which we're going to use for our MongoDB stuff here in a few minutes. All right, nothing's in there, nothing special about it right now. And then finally, we're going to do an npm start. So this is something I think that goes with this new, what do we call it, the express structure thing, the express generator. So now we use npm to go ahead and start the application, start our server. And then we should see this after we do it. So let's go in there and do npm start. All right, so it's serving like it did last time. So now we can go to localhost 3000. Let's just open this in a new tab. Did it open in a new tab? There we go. Localhost 3000. Welcome to Express. So we have a server running. Great. Okay. So we're going to go ahead and open up our app.js. Let's go back over to our Sublime here. I'm going to go ahead and open that file. So I'm going to go into, I put it in my Dropbox, and then inside of CW, then 518, then mean test, and app.js. All right. So here is our starting project dealy flippy thingamajig. All right, so let's just look what code they give us by default. So they're bringing in Express, they're bringing in path, favorite icon, Morgan, cookie parser, body parser. We're not using the Mongo stuff yet, so we don't know whether that's going to break or not. So here's our app express, just like we had before. We're setting some things here. So we're setting views equal to the path views. This is a directory that was created for us. So these two lines right here are part of what we're seeing happen from this directory structure that was just created. So rather than having everything inside this one big file and us just working with it all locally, we're saying we're going to keep our views here in this directory called views. And we're going to associate that with this app.setViews. This is just a variable. And then we're going to say app.setViewEngine. So that's our template engine for letting us write HTML in one place and then being able to inject into it from someplace else. We'll see it as an example here. That engine we're going to use is Jade. So that's a common template engine. Okay. This is the favorite icon thing. I said after you put your favorite icon in /public, you can uncomment this and magically it will just work. In fact, we could probably pick a favorite icon if we wanted to and then uncomment that and see it. Okay, so we're using Logger in development mode. We're using something called body parser specifically in JSON. So this is a tool for pulling out information that gets sent in from our endpoints. We'll see it in action today. I don't know if this is even necessary, but usually URL encoded would be like UTF-8, which is like a Unicode way of encoding URLs, but that should be the default. So we'll see what happens there. Cookie parser is a way of remembering information from one screen in your application, on one screen in a website to another. So that's actually an interesting problem that for those of you who have done some software development in mobile, if you have an iPhone app or an Android app and you have this screen of the application that needs to get some information over to this screen, you can just, when this screen creates the screen, he sends in that information. Or we've more recently been looking at things like singletons, where we store all the crap that we might want to have in this one global bucket that both of these screens have access to. Problem is that the web doesn't live here. It's on a web browser somewhere. And if you're going from one page in a web browser to another page in a web browser, and we need to have information shared between those, the server kind of has to maintain that. And that's where this idea of a cookie comes in. Okay, so we'll see those, but that's what that guy's there for, is allow us to have information pass through multiple pages in our web application. Hopefully when we're done with this, you'll all hate web applications as much as I do. Okay, so that's cookie parser. And then here's our, for Express, any static pages that we want to serve. So for instance, if we have a page that's just, hello.html, for example, not going to get pre-processed, not going to run through our server. It's literally a static web page that we want our Express server to serve. We would put that in our public directory. Make sense? All right. And then here's for routes. So app use / it's going to go to something called routes, and we'll look at that. App use, that's this guy up here, routes is routes index. So we have a folder that was generated for us called routes, and inside there we're going to have a list of our routes. So last time we had one document that had our routes right inside there, right? Now our routes are actually kept someplace else, and this guy will read from them. So it ultimately all comes into the same document. We're just kind of putting pieces in different places now. All right, so our routes will live inside of the routes folder. Our users will also live inside of the routes folder. App.use, so here's the function. So for a page that's not found, the standard HTTP return error for a page not found is error 404. So if you've ever been to a page and it says 404 not found, something like that. So this is, for any error you run into, just here's the error, not found, status 404, not found. So just this hands things off to the error handler. Okay, and then let's see. Oh, because we're in a development, we're in development mode, if you will. Whenever we do run into an error, this will print out a stack trace for us, kind of showing us all the things that happened prior to the error so we can hopefully figure out where the error actually occurred. When we're in production mode, when everything's tested, everything's worked out, we probably want things to run a little bit quicker and go through less logging and stuff like that, so we'd probably turn development mode off. But right now, it's in development mode, so we can see, hopefully, the crumbs from any errors we have. Let's see. Yeah, here's the production side of this. So if we're in development mode, do this. If we're not, do this. Okay. So that's our current server. This is the current guy that's handing those things off. So what I'm going to open up next is we're going to go into our routes folder, and we're going to look at that index file. So let's open up. We'll go into routes, and here's our index. All right, so notice here that we have the slash route, and what does this dude do? He renders this file called index with the title express. Well, let's go and look at what this guy is. This is using that Jade template engine we talked about. So rather than this guy outputting HT, remember last time we, our slash hello guy, here I'll bring it out actually just so we can see so this was the crappy one we did last time. There we go. Yeah, so here was the slash thing. What did we do? We just spit out hello world. But now let's say, here's what this site looks like right here, right? So I'm going to right click on this, and we're going to view page source. That guy looks like this. So I'm going to highlight all that. So now, because it was HTML, I'm going to go back in here. Instead of printing out hello world, we're actually going to print out all that crap. Okay, but wait a minute, some of this stuff, oh, we have double quotes here with the backspace those, because that's not going to work. Same thing here, we got to backslash those. We can see pretty quickly that this is going to be tedious. So if you're outputting HTML like this as direct parts of your routes, this is for a very, very simple web page. Oh, lost it, so web page is dead. There we go. Would you say this is a pretty simple web page? Right. So as our web pages get bigger, this guy becomes more of a nightmare. Not really what we want to do. Okay, so this is the problem that template engines solve. So remember in the early days with PHP, you would have plain HTML with PHP embedded in it. But now what we have is we have a RESTful API endpoint. This is the slash endpoint that is being asked to respond with something. Now, if we are assuming we're talking to a web browser, what we should be responding with is HTML, JavaScript, and CSS. So that's what I'm doing here. I'm responding with HTML, JavaScript, and CSS. Last time we had it easy because we didn't assume we were talking to a web browser. So we just put hello world in there and everybody was happy. Just text. All right, and the web browser just said, okay, well, this isn't HTML. I'm not going to try to do anything fancy. I'm just going to spit it out on the screen. Good luck. Well, now we want to send out something like this. All right, so we can see this is going to be pretty tedious if we do it directly like that. So I'm going to not save that. So notice here that we are using we're taking our result and we are choosing to render something. And our rendering is happening through Jade from what we had set up on the previous screen. So what we're rendering is a file called index, and we're passing into it, we're injecting into that template a value express for a variable named title. Okay, so let's go look at that template. So I'm going to go open, go back up a level. It should be in views. Here's index.jade. So this guy extends layout, which says that that's the basic web page. So unless you have a real good reason, all your Jade templates should extend layout. That's the plain Jane, hi, I'm a basic web page, HTML, head, body, all the normal tags. Okay, then we have a block here called content. H1 is equal to title. So H1 is a header line. So if we wanted this to be smaller, we could change this to H2, H3. So the HTML equivalent of this would be H1 title / H1. That's the HTML version. This is what Jade lets us do. So Jade is like a cut down version of HTML. So not only do we get the power of the template, we also don't have to write as much HTML. Jade does the extra work for us. But that comes at a cost. That cost is indentation. When you look at this, we actually see how a template engine works now. When we say welcome to, that's a placeholder for title, right? Let's go back here to the actual screen. Here's our title after H1. Here's our welcome to. Here's the other title after H1. Now remember, this is all because in our code here, when we render, we're passing it, this is a JSON object, right? With a name value pair. We're saying title is equal to express. Okay, well, if I change express to just say the word elephant, and then I save that, and then we reload. Oh, hold on, I need to restart the server. We get elephant. When you make changes local on your local Node.js server, you have to restart it. When you make changes to a remote one, usually when you push the change, it automatically restarts for you. Just more of a thing you have to remember. Okay, so back in this template here. The h1 equals directive for Jade says, I will wrap this variable name inside of h1 tags. This is the paragraph directive. So this is for opening tag P, closing tag P. And what will it do? I will put whatever you say here, and this is allowing us to embed this inside of another value. So I could replace this and just say title there like that. And notice it does not pick up that. If we look at the title here, don't these guys match? Maybe I say P1 equals, or just P equals title. Save that. Now we have our elephant. If any of you have ever worked in PHP, PHP has these equivalents. All right, so in PHP, what you could do is you can decide that you want something to boil down to a variable. Or you can decide to effectively concatenate the value of a variable as part of a string. And that's what we just done. That's what we've just done here. So what we had here before, just go back twice, is we're saying up here, I want this h1, and by putting this little equal sign here, we're saying boil down this variable. That's it. Everything after that equal sign is going to become that value. Now you can't just decide you want to throw that equal sign willy-nilly anywhere in there. So for instance, does that mean I should be able to do this? Let me just take this out. And actually I'm about 90% certain this doesn't work. It doesn't work in other template engines. I haven't worked very much in Jade. But typically this equal sign would have to be part of this tag. So I don't think this will work. Yeah, welcome to title. Does not work. All right, so we really needed to make the decision up front. We're either going to have this guy boil down to just a value, or we're going to use this syntax for embedding this variable somewhere within our text. And then at runtime, when it goes to render this template, it will replace. It notices that pound sign, opening curly brace followed by a closing curly brace at the end is our placeholder for our variable. Make sense? All right, so, and we'll see if we want to have it say elephant twice. We can say woot elephant, something like that. Oh, need to restart the server. So there's the welcome to elephant, woot elephant. So we're seeing how that template engine works by letting us inject values in there. Similarly, I can come in here and notice I'm saying render in index title elephant. Well, I can give it then blah woot as a second value. So now I can go back to the template here, and I'm going to put blah in there. So a second value I'm injecting. Welcome to elephant, woot woot. Make sense? So template engines, not all that big of a deal. They sound more complex on paper than they are. The biggest thing with Jade specifically, there's a couple other ones. Jade is actually related to, I'm trying to think of the name of it. It's a Python one. It has a similar, like a gem sounding name. But whatever. It's related to that in name. And I've worked with that one before, obviously, since I don't even know the name of it. It's just escaping me now. I'm getting old. But they're very specific on indentation and things like that. Right? So what they're trying to save you, right, having to write all this extra HTML and stuff like that, at the cost of, I guess, things being kind of a little bit anal when you write it. It also has another thing. I think there's some websites I've run into before. Let's say that you find some nice HTML code that out there that you like, oh, I like this, and I want to at least modify this a little bit for my site. Well, that's not in Jade template format. I think there's a website out there that you can dump HTML into, and it will spit it out in Jade. That will be handy. So we'll look at that when we actually start trying to make our site look moderately real. But I want you to keep your expectations real low in terms of how good this is going to look with me at the helm. Maybe some of you are more artistic than I am, but pretty good on the code side. When it comes to graphics, I tend to grab a lot of Teenage Mutant Ninja Turtle pictures and Mario. What else we had? We have Jabba the Hutt. Oh yeah, we had Rickroll. Yeah, so what was it doing? Okay, so let's just go back here. I was looking at the code. Let's just get ourselves to a reasonable stopping point, then we'll take our break. All right, so the render stuff makes pretty good sense. And what's nice about this now is I can basically steal this line. And I can do a /hello. And then I can have this guy, I don't have to use the render. I can do a response.send hello world. Something like that. So I'm using the same response thing that was sent. But instead of passing it through my Jade renderer to render a template, I'm just going to send back some text, which we might sometimes want to do, especially when we're going to have our iPhone app talking to this, right? Sometimes we want our iPhone app to send in a request and this guy just spit back out a response. Probably want the response to be in JSON, but it doesn't have to be, right? So I mean, if you really want it to be in JSON, we can just format this in JSON, although there are some template engines specifically that let us do JSON. But is there really a reason why we couldn't have Jade do JSON for us? Not really. You don't get to benefit from some of the built-in stuff, but I think Jade should be able to handle JSON for us pretty easily. In fact, we can even test it here. Let me, I'm going to steal this for a second. And we're going to call this guy hello.jade. We're just going to paste some stuff in here. So that's some JSON stuff, and we're going to say value. Actually, let's do it this way. Something like that. Value. So this is just a template. I think Jade will be okay with this since we didn't use any of their directives. So we just wanted to spit out everything that's on here, except replace that guy with whatever we pass in for value. So we'll save this. This guy's called hello Jade. Go back into our code here. Oh, it's actually back here. So we'll still render. Except now we're going to render the hello template, and we have something called value, and we'll set the value to hello world, and we no longer have this blah dude there. So we want to render this template with this JSON collection of name value pairs. And let's see if I'm right in that Jade will support this as long as we don't use any of their directives. So we want to go to the /hello endpoint, row, didn't like that right off the bat. I don't think we're going to be able to use Jade for JSON. We'll have to use another third-party thing for templating JSON. Not the end of the world, but it's a thing. Okay, so where are we in the tutorial? Just so we remember where we're picking up. All right, so all of that seems to be working. Here are those routes. That's our hello world thing. We already did that. We looked at that. Okay, so let's take a break. We'll come back and we'll start messing with MongoDB. Sound like a plan? So let's do 20. So we'll be back at 8:21 or so.